This section is about multiplying and dividing rational expressions. A rational number is a fraction. The root word of rational is ratio, which is a over b or a to b. So the ratio of two polynomials is a rational expression, and that's what all of this is about. If you solved a problem, you would not leave your answer unsimplified. So in this case, we have an improper fraction, 12/8. You would simplify it. The way that you would do that is you would find what is my common factor in my numerator and denominator, and let's have those cancel out. So in this case, you realize that 4 is a common factor. 4 is the largest number that goes into both 12 and 8, and you're left with a 3 on top and 2 in the denominator, such that you cancel out your 4's, and you're left with 3 halves. So you just cancel those out. Because they're being multiplied together, we can do that, and this simplifies down to 3 halves. You can only cross out common factors, which are the things that are multiplied together. You cannot cross out things simply because they're added together. And here's a quick example. A lot of students are tempted to see a problem like this, 2 plus 7 over 2 minus 1, and say, oh, there's a 2 in the numerator and denominator, let's get rid of those. Answer, -7. You can't do that. Just think about it. If you solve this, you're going to get 9 over 1. But if you cross out the 2's, you get -7. It's a different answer. You've actually changed the problem by doing that. Whereas here, that's not the case. When we multiply something together and then we cross things out, that was a legal operation. Mathematically, it did not change the problem. So make sure that when you're factoring things out, it's only things that are being multiplied together. Here's an example. In order to simplify something like a to the 4th b minus 2a to the 4th all over 2a to the 3rd minus a to the 3rd b, we need to start by factoring out our common factors in our numerator and our common factors in our denominator. First thing I look for is I see this a to the 4th term. I want to see is there any other a's in the numerator, and yes there is. We have an a to the 4th over here in this term. So when I go to factor, I'm going to factor that a to the 4th out front, and I'm going to have a b minus 2 left over. So I'll throw that in parentheses. Same idea in the denominator. Do I have any common terms? See an a to the 3rd here, a to the 3rd over here, and then I have a 2 and a b, so nothing in common there. So same idea, I'm going to pull my a to the 3rd out front, and I'm going to have a 2 minus b. Just for consistency, I'm going to go ahead and highlight these so you see where these came from. So we have it factored down, but we can continue to simplify. One little trick is we see we have a b minus 2 and a 2 minus b. They don't actually cancel each other out, but they look similar enough that it seems like there's something we can do. And in fact, there's a little mathematical trick that you can do, and I'm going to show you how that works here. If you multiply something times -1 twice, you're effectively doing nothing, right? Because multiplying by 1 is a legal thing, it doesn't change anything. And multiplying by -1 and -1 again is just multiplying by 1, right? Because -1 times -1 is 1. And so what we're going to do here is we're going to do a little mathematical trick. We're going to take this term here, and we're going to multiply the inside by -1. So 2 times -1, -2, negative b times -1 is positive b. So we multiply that by -1. And to undo what we just did, to offset it, we threw a -1 term right next door. So this equation up here and this equation down here, or this expression up here and expression down here, are both still equivalent because what we did, we immediately undid. However, if you notice, this is addition, we can just rearrange our terms from a -2 plus b to a b, or -2. So let's do that. The only thing that changes is we swap these terms, and since it's addition, you can change the order with no consequence. And now our numerator and denominator look the same as far as that b minus 2 term. So this is where we can start having fun with canceling. We have a b minus 2 up here, a b minus 2 down here. Let's cancel them out. We have an a to the fourth up here and an a to the third here. So what we're going to do is we're going to be subtracting our exponent. 4 minus 3 is a positive 1, so we're going to be left with a to the first in our numerator, and our denominator a's are going to be gone, so that's a to the first power up here. And we're still left with our negative 1 here, so we'll leave that there. So we have a over negative 1 all left, and that just simply goes down to negative a. So this big nasty expression here simply boiled down to negative a if you factor it all correctly. Let's do another example on this side. X to the fourth y minus 3x to the fourth over 3x to the third minus x to the third y. Very similar to this problem that we just looked at. See, in the numerator we have an x to the fourth, another x to the fourth, and then we have a y and a 3 left over. Nothing in common there, so that's as far as we can go. Denominator, same idea. I see that I have x terms in both. In fact, both have an x to the third specifically, so we can highlight those and pull those out. A 3 and a y, nothing in common between those, so that's all we can do there. So let's pull that out front, and we can rewrite what we had, so that we have the x to the fourth out front times our leftovers, y minus 3, and in our denominator, x to the third times our leftovers, 3 minus y. If we get it this far, we see it's very similar to what we had over here with the b minus 2, 2 minus b situation. So we're going to apply that negative 1 trick. I'm not going to show you all the steps this time, but we're going to flip the order of these two and put a negative 1 term right next to it. Because in effect, we're doing the same thing we did here, where we multiplied the inside of this by negative 1 and undid it outside with a negative 1 term. Same thing happened here. Always remember to undo any operation that you do in an expression so that you're not actually changing the problem as you go. Now it's time to cancel things out. So we have y minus 3 in the numerator and denominator. Those can cross out. X to the fourth over x to the third. 4 minus 3 is 1, so we do subtraction of our exponents whenever we're dividing. So that will completely go in the denominator. The numerator goes to x to the first power. And once again, we have x over negative 1, just negative x. So all this stuff simplifies down to negative x.